So let's go ahead and look over another question, which is a cubic function type of question. Now in this video, basically, I'm going to be taking through 8.1, 8.2, 8.3, and 8.4, right? So which means you can basically jump into whichever question that you want, but I would advise that you watch everything because I'm going to be dropping some more info as I go into each and every question. So let's go ahead and read the instruction that we have here. So sketch below is a graph of f of x, which is equals to x cubed plus ax squared plus bx plus c. The x-intercepts of f are 3 to 0 and m, where m lies on the negative x-axis. K, which is raised to minus 3, is the y-intercept of f. M and n are the turning point of f. Alright, so now here, you see that we're given a cubic function, alright? And now about this cubic function here, we can see that we're given the first value there, right? It is 1, right? So there's the first unknown, the first coefficient next to x cubed, it is 1. And then also we are told that we're given x-intercepts. So whenever you're given x-intercepts, it means that this formula, it came from x-intercept method or x-intercept form, right? So what is that? We're basically going to discuss that when we answering our very first question, which is 8.1. So here they're saying that we must show that the equation of f is f of x, which is x cubed minus x squared minus minus 5x minus 3. So x cubed minus x squared minus 5x minus 3. So the first thing that we're going to do here is we're going to check what we're given. If you see here, we're given x-intercepts. Now because of that, this means now f of x will be written using the x-intercept formula, right? Now here, normally the x-intercept formula for cubic function is usually a into x minus x1, x minus x2, and x minus x3. But they already used a for something else. So instead of using a, I'm just going to use d, but then I'll still write the same thing over there. This is just to make sure that you don't get confused and substituting the value for a because you don't even know what the value of a is at the moment. So we have x minus x1, x minus x2, and x minus x3. Then from here, we know that that value d here is exactly the first value with x cubed. So in this case, it is 1. So which means now here, when I'm substituting it, I will just leave it as invisible 1. And then for x1 and x2, if you see on the graph here, we have our turning point here in the x-axis. So our turning point, when it becomes our x-intercept, it then means now this x value, x as x1 and also x as x2, whereas this one will then be the third x value. So what we're going to then do here is we're going to substitute that value. So that value, I will say it is x coordinate of m, so I'll write it xm, right, like that. Just fix this, okay, and then I'll basically substitute it also here, and then the third one will just be minus 3. And then from this one, you can see that this is basically y equals to x minus xm all squared and x minus 3. And then from here, once I get to this point, I can see that in order for me to find this x value here, I must have a point that has x and y coordinate. And then here, this is basically where this point comes in. This is the y-intercept, right? Usually the y-intercept, when interpreting cubic function, has no meaning. We can't use it that much. We can always sometimes use it as a point. In most of the time, I'll always approach it as a point. So that's basically what we're basically going to do here. I'm going to be substituting this value, given that this is the x coordinate and that is the y coordinate. When we do that here, we basically get minus 3 equals to 0 minus xm squared and 0 minus 3. Now this gives us minus 3 equals to, here we have minus 3, so I'll say this is minus xm squared, then I'll say this is minus 3. Now minus xm squared gives you xm squared, but then we have that minus 3, so I'm going to put that minus 3 up front there, and then have xm squared. And of course, I want to divide by 3 both sides from here, and then 1 will be xm squared, then I'll put the square root both sides. So now here xm is going to be a plus minus answer, right? Plus minus 1, but since the x coordinate needs to be negative, so this will be -1. Now what does this mean? So this means now our equation will be x minus, if you remember, we had xm squared there. So xm, I know now it is minus 1. So I'll square that, and then I'll have my x minus 3, and then this will be x plus 1 squared, x minus 3, and then this will definitely be x squared plus 2x plus 1 into x minus 3. Then from here, we're going to basically multiply everything out. This with that and that, this with that and that, and also this with this and that. Okay, so let's go ahead and do that. So here the first one gives us x cubed minus 3x squared. The second one, it gives me 2x squared minus 6x, and then the last part there, it gives me 1x minus 3. Now when you simplify this, what does it give you? So it gives you x cubed minus x squared minus 5x minus 3, and that is basically how we get our value there. Okay, so now let's move on and look into the second one. Second one here, it says it's calculate the coordinates of n. Now we know that the coordinates of n, it is the intercept here, right? So basically what we're going to do is we're going to first calculate the derivative, because we know that the turning point, not intercept, turning point. The turning point is basically the derivative of the cubic function that we're going to need. So I'm going to differentiate this, and then I get 2x squared minus 2x minus 5, right? And then from there, I'm basically going to say, now in order for me to find the turning point, I'll take the derivative and equate it to 0. And then that will mean that I'm taking 3x squared minus 2x minus 5, and I'm equating that with 0. So now I need to factorize this. Let's see, here I have 3x, and then here I have x. Now right here I need to have 5 and 1 and minus and plus. So basically for this case, x is going to be 5 over 3, and for that case, x is going to be minus 1. Now looking at this, you can already see that this x value was the x value that we got for m, and then this is going to be the x value for n. So which means now to get the y value, I'm going to take this one and substitute it on the original equation. So now here I have 5 over 3 cubed minus 5 over 3 squared minus 5 into 5 over 3 minus 3. So now from here, I'm going to go ahead and press this onto our calculator. So pressing it into our calculator, I'm just going to try and move as quickly as I can. So minus, okay, so what I did, I just paused the recording and then just wrote this. So this gives me basically minus 256 over 27. So just to save time, minus 256 over 27. So this basically means now n, it is 5 over 3 is to minus 256 over 27. All right, let's have a look at 8.3. 8.3 says that here that for which values of x will f of x be less than 0. Okay, so what does it mean when they say that f of x is less or equal to 0? So less or equal to 0 means that we need to look for the graph where it is below the x-axis. So I'm going to write it here. This means two things, right? It means it is below the x-axis, right? So that is the part of less than 0. So this means f of x is less than 0, and then that's what it means at the x-axis. So the second one is basically where we're saying f of x is equal to 0, because this thing it's saying for which values of x is f of x is less or equal to 0. So yeah, so when we see here, we can see that this graph, it is where it is below the x-axis here, and then it is equals to, it is at the x-axis between those values. So which means now here, if I start at 3 and then I look at all the values that are at the left of 3, I'll see my graph is below. But then if I include 3, including 0 and all of those values on the left, it means I'm also taking into account of the x values that are at the x-axis. So that's how we get into our answer. So let's go ahead and look into the second one. So the second one, 8.3.2, it says increasing. So if f is increasing, what does that mean? So basically, if f is increasing, I wrote there is increase, so weird. If that is increasing, it basically means now that the derivative, right, it is greater than 0, right? In other words, derivative is greater than 0. It means on your graph, you just need to look at where is the graph going up, right? You can see that the graph is going up here, and then it's also going up there, right? Now, when you're looking at this, you need to compare it using the critical values. So the critical value of this, it is the turning points in this case. So here, we see then that if I'm looking at the left of this value, if I'm looking at the left of -1, I will see my graph going up. And also, when I'm looking at the right of 5/3, my graph will also be basically going up. So that is the value for that one. Now here I'm going to go to 8.3.3. So now here it says f is concave up. So what does concave up mean? So concave up basically means now that the second derivative is greater than 0. Now according to the diagram, it means where is the graph smiling, right? So looking at this now, I'm removing that, I will see that this graph is smiling starting somewhere there. But the problem is that I'm not sure what is the actual value where this thing is starting. So what I'm going to do here is I'll first find its second derivative, right? Luckily, I still have the first derivative. So now the second derivative is going to be 2 times 3, which is going to be 6x, and then it's going to be -2. So now to find that value, I'm going to say the second derivative must be greater than 0, right? And then here, of course, 6x minus 2 must be greater than 0. 6x must be greater than 2 divided by 6 divided by 6. Now x must be greater than 1/3, and that is how we find our equation. Now let's move on into the last question. Now this is the very interesting question, right? And please, by all means, if you manage to get this one, if you manage to get into this question right now, it means you're going to be doing something good for yourself. All right, so let's go ahead and read the question and answer what it is saying. So here it's saying, let's determine the maximum vertical distance between the graphs of f and its derivative in the interval -1 and 0, right? So here they want us to calculate vertical distance and find its maximum vertical distance between the cubic function and its derivative. So what are the things that you're supposed to do here? Firstly, there's a keyword here. The keyword, it is maximum, right? Whenever you hear word maximum, I'm sure this is something that has been done in functions, that is in the parabola most of the time. When you talk about maximum, we always used the critical values, right? We always use critical values to basically determine a maximum distance or maximum vertical distance. So what does this mean? So this means the first thing that we're going to do, we first need to write both of the equations that we have. So here I have x cubed minus x squared minus 5x minus 3. And then my question will be this: what are the critical values of this graph, right? Now the critical values, so I'm just going to see RT value, right? The critical values of this will be the x-intercepts and the turning points, right? So with this case, I'll start with the x-intercept, right? Now the x-intercepts here, it will basically be the points that we have on M. -1 is to 0. Oh, let me just give you the x values. Let me just write the x values. So the critical values, it's happening at x is equals to -1 or at x is equals to 3. So that's the first critical value. And then the second one is on the turning points. So on the turning points, this happens, of course, at x is equals to -1 or at x is equals to 5/3. And then another critical value, it is the point of inflation, right? Or point of inflection, not inflation, inflection. Point of inflection, it is going to be, I think it was 1/3 that we got today. Yes, 1/3, right? Now, these points are called critical values because they're changing the behavior of the graph. For example, here, if we're looking at x minus 1, anything that was happening before and after, there's a change. For example, before minus 1, we can say it was going up, then after it started going down. So that's a critical value, it means there's a critical value. And so in all of these points here, these are the critical values, right? So now we're going to look into the second part. Second part, it is the equation of the derivative, right? So the equation of the derivative, it was 3x squared minus 2x minus 5. All right. So now what are we going to do? We're going to do the same thing. We're going to look for the critical values that we can find here, right? So the first critical value that I can think of course, it is always the x-intercepts, right? So the x-intercepts, luckily here, we did actually solve this when we were looking for turning points. Where was it? Here. These values are the first critical values of this, because if you're looking at this from this point, right, from the derivative point, then these are the x-intercepts of this graph, right? So which means we're going to use x equals to minus 1 or x is equals to 5 over 3, right? Now, what is the another critical value of a parabola? Of course, it's going to be the turning point, right? Now, the turning point of this, of course, it is going to be what? It is going to be that x value that we got there, right? Because remember, if this was the original equation, let's say this was maybe h of x, right? Now, if we wanted to find its turning point, we're going to say h of x equals to 0. Now, this part going to give us 1 over 3, right? So this basically means now here, the turning point, the x coordinate of that, it is what? It is 1 over 3. Now, after we have found all of these values, remember the question, it wants us to find the vertical distance. So which means now we're going to look out of these, that which point between these is within this interval between minus 1 and 0. Now here we can see that minus 1 is not there because we didn't include that. So we're going to take that one out. Take that one out. Of course, definitely that one is out. That one is also out. But then here, when you're looking at this one, we can see it is within. Then this is out. This is out. Of course, as you can see, this is also within. Now, what does this mean? So this means now here, the vertical distance that we're going to calculate, we're going to basically calculate it using this x coordinate, because that's where we see an x value that has a critical value, right? So now that we have found our critical value, now we're going to say that we're going to let the x value to be 1 over 3. Why is this? Because this is our critical value that is within minus 1, x and 0. And from there, I'm going to calculate what is the y value of this. So I'm going to use the cubic function and also use the parabola, right? So now here, sorry, the derivative here. So now firstly is going to be that of the cubic function. So that will be 1 over 3 cubed minus 1 over 3 squared minus 5 into 1 over 3 and minus 3. So now we're going to basically press this in our calculator and see what it gives us. Okay, so pressing our calculator, you can see that this gives us minus 128 over 27. So we have minus 128. So this is equals to minus 128 over 27. All right. And then from there, we're going to do the second one. So now the second one, we're looking at it on the derivative. So now, of course, we're going to look at that point. And this basically means now we're going to be taking 3 into 1 over 3 squared minus 2 into 1 over 3 and then minus 5. So let's go ahead and press also this one into our calculator. All right, so pressing this in the calculator, it gives us negative 16 over 3. Okay, so negative 16 over 3, so negative 16 over 3. Now, of course, with this one, we need to see that which one is at the top and which one is at the bottom of this, right? So basically, I'll just take out my calculator again, and then I'll check what this value is. So this is like a minus 5,33. So this is approximately to minus 5,33. And then whatever the second one that we had, let me just go up. Okay, we remove that one, but I'm going to just type in minus 128 over 27. Let me see what that gives me. So this gives me minus 4,74. So minus 4,74. So I'll say minus 4,74. Now we know that when we're talking about vertical distance, so therefore the vertical distance, we know that it is the y value at the top minus the y value at the bottom, right? But not only that, it is an absolute value. So the absolute value means it is a positive of that, right? So now what I'm going to do is we'll first calculate the difference and see what we get, and then that value that we get there basically means in the end we're going to make it positive. So the y value at the top, of course, is going to be the one that is at close to 0, which is minus 4,74. So minus 4,74 minus, and then minus 5,33. All right, so press this in a calculator now. So we're going to say minus 4, or rather, let me press exactly the ones that we got as fractions, just to make sure that we get the exact answer. So I'm taking minus 128 over 27, right? And then I subtract it with minus 16 over 3. Let me see what that gives me. So as you can see here, it gives me 0,59, right? So which means that is going to be my vertical distance. So 0, let me just see here, 0,59. So that will be my maximum vertical distance, right? And that is how we find this vertical distance. Now this is very interesting. If you like the video, please make sure that you leave a comment. Tell me what do you think about this video, and also especially this last part, because this is the part where people are very struggling when it comes to maximum vertical distance. The word maximum, remember, it means critical values. It means you define the x values of the critical values. And I'm going to see you on to the next video. Cheers.